Don't let me forget to give this to her. She left it here last time. Share screen, share. Where's this? So let's see. Today, elementary algebra. We're going to continue our final exam review. And your columns picked out for us. Forget where we left off. Let's see. Those last time. So for we only covered section 10.6 in chapter 10, and then we had 13.1, 13.5, 13.6, and 13.7. And so get a little progress there. So for number 8 on the exam, I'll give you something like this. So let's make some room here. Work these. So this formula here converts degrees Fahrenheit to degrees Celsius. So if we want to convert 32 degrees Fahrenheit into degrees Celsius, we use this formula here. So let's use this formula. So what we're going to do here is replace the sorry about that, the degrees Fahrenheit. We have, I guess I can leave out these for now. What? Are they what? They just came out of the book here. Yeah, I just looked at the section and just kind of made some problems up. They probably are in the quizzes. So we want to have 32 degrees here, Fahrenheit. So we replace the F with 32. So we get 5/9 times 0, which is 0. So this would be 0 degrees Celsius. So 32 degrees Fahrenheit is the freezing point of water, right? So in degrees Celsius, the freezing point of water is 0 degrees. Let's look at another example. So we know 100 degrees is when it's pretty hot outside, right? So I'll use our formula here again. But this time we'll replace Fahrenheit with 100. So we get 5/9. See, 100 minus 32 is 68, right? Let's use our calculator. And we have 68 times 5 divided by 9, and we get 37.7 the bar over. Actually, yeah, we can do that. Degrees, which is approximately 38 degrees, right? So we could put here either 37.7 with a bar over it, or you could round to 38 degrees. I shouldn't put the degrees here. All right, it's understood that we're working in degrees, right? So this is a straightforward thing. It's just plug and chug, all right? And so these were from section 10.6. And then I wanted to throw in another one from 10.6. So these are all part of part A here, number 8. So if the perimeter of this triangle is 20 feet, find X, right? Make sure I got that over here. Yeah, solve for X. I just kind of left that out. Okay. I guess if I say find X, you're going to be like, here it is, right? But no, that's not what I want. So I should be more specific and say solve for x. All right, so if the perimeter is the sum of all the sides, all right, we could see that x plus 6 plus 10 would equal 20, right? So what we're saying there is that x plus 16 is equal to 20. And if we subtract 16 from both sides, we have x equals 4 feet. It's as easy as that, okay? So the perimeter again is the sum of all the sides. So we add up all the sides, we should get 20, and then we solve for x. So that was everything for 10.6, and we moved on to chapter 13. So I picked out some problems. I invented some problems for 13.1. So for this first one here, when they say evaluate, what they mean is plug in the number that's given for the variable. So negative 5a squared, if a is 2, this is negative 5 times 2 squared. And you just replace a with the number 2. So this would be a negative 10 squared to be a negative 10 times a negative 10, which would be 100. This one's very similar. Evaluate, so 6x plus y. If x is 1, we replace x with 1, and if y is 2, we replace y with 2. So we get 6 plus 2, which would equal 8. So this one, we have a plus b squared. And then they tell us what a and b are. So all we have to do is replace a with 4 and b with a negative 1. So 4 minus 1 is 3. 3 squared is 9. So that one's not hard either, right? It should be really easy. And I didn't make it to part C yet. So let's take a look. I was looking at 13.1. I think that's good enough for 13.1. Let's see. Now we need to have some simplifying the expressions in here. So let's look at, what was the other sections? It skips to 13.5, 6, and 7. So let's look at 13.5, 6, and 7 here. 2.1. 13.5. Okay, so these were vocabulary, how to add polynomials. Okay. And the opposites, subtracting. Okay, so let's create a problem here. Let's say 1. I think we can do them all as simplify. Need an L. Simplify. So let's make this one like 5 cubed a cubed b cubed over 5ab squared. So that's a good problem for y'all. And now let's do one where you kind of combine stuff. Let's do a 3x squared y plus 4xy plus 5. And then we'll add to that 2x squared y minus 3xy plus 2. So So those you'll just combine like terms, okay? And now let's invent a new problem. Let's see, adding and subtracting. That covers adding and subtracting, I think. We already did perimeter stuff, so let's go to the next one, 13.5. Yeah, 13.6. Let's pick out some stuff from here. Okay, multiplying monomials. I think you'll have that down. Assuming the next section will be multiplying polynomials. Yeah, let's do one of those. Let's see. Let's do another simplify here, and then I'll make part D something else. So let's do this one. Let's do a subtraction. Let's do 2x cubed y squared plus 4x squared y minus 3. Now we'll subtract an x cubed y squared and an x squared y. And how about just a 2x? We'll throw a 2x in here. Leave it like that. So that'll be good. We'll work that one in a second once we finish out these problems for this section. So part D, we want to be able to multiply stuff like this, okay? So we can do some multiplication here. All right, so we want to multiply polynomials. I'll throw some of those in there. Let's see what 13.6 wants from you. Right. 5, 6, and 13.7. Okay, so we would need to be able to multiply and be able to divide polynomials. Okay. So those are simplified. So let's do 2 of them that are multiply. Multiply. Let's do 2x plus 1 times a 3x minus 2. And another one, multiply 3x minus 2 times 4x squared plus 2x plus 1. And now I'll give you one of these that'll be a divide. And let's pick out something they got here. Divide the polynomial. So this one looks pretty easy. Okay, so it's 13.7. We'll do one like this. 3x squared plus 2x minus 5. 3x squared plus 2x minus 5 divided by x plus 2. So that should be good for chapters 10 and 13. So let's work these then. Okay. Wait, we just did these, didn't we? We just did B. We need to do C and D. All right. So the test is going to be really long, all right? But a lot of these problems should be real quick, all right? A lot of these are real simple. So let's look at, hey there. Somebody brought goodies. Awesome. All right, so if we want to simplify these, if you want, you can write this out. 5 cubed is 5 times 5 times 5 A cubed is A times A times A. A B cubed is B times B times B. Then we have a 5 times an A times a B times a B. So you can see that the 5s cancel, an A cancels, you cancel 2 B's here. Then you're left with 5 times 5, and then A times A and a B. Right? Basically, you subtract. This is really 5 to the first power. So you take a 3 and then minus a 1, and you get 2 5s left. Okay. There's 3 A's on top and 1 on the bottom. You get 2 A's left. 3 B's on top and 2 B's on the bottom. You're left with 1 B. Okay. So this one, oops. All right, if we want to simplify these, we can combine like terms. If you look at this and this, right, that's 3x squared y, and then we have 2x squared y's, and then we have a 4xy and a minus 3xy. We have a 5 and a 2. So all I did was reorganize them so that we can kind of group these together. You see, these are like terms. So 3x squared y's plus 2x squared y's gives us 5x squared y's. And we have a 4xy minus a 3xy. That leaves us with a single xy. And then 5 plus 2 is 7. So just combining like terms. Oops. Now this guy here is very similar, except we're subtracting now, right? I want to make sure. Okay, good. All right, so we have our 2x cubed y squared. I'll just copy this. Let's deal with this minus sign first. We have to distribute this minus sign to everything in there. So we get a minus x cubed y squared, and then a minus x squared y, and then a minus 2x. So now we can group our like terms. We have this 2x cubed y squared. We have x cubed y squared right here as well. So let's move that one over to go with this one. Now we got this guy. Let's keep it. And let's look over here and see if we have one. We have a like term. So let's put that one with this one. Put those together. Then let's see, we have a minus 3 and we have a minus 2x. Those don't have any like terms. So those are kind of on their own. So now if we can combine, we look right there, we have 2x cubed y squared minus 1x cubed y squared. That leaves us with a single x cubed y squared. And if we look at these, we have 4 of them minus 1 of them. That gives us 3 of those. Remember, the powers of the variables have to match, right? This is exactly the same as that. They have to be exactly the same to be a like term. And then we have this over here left over. I'm going to put the 2x first. It doesn't matter what order you put them in, but it's nice. You notice I put these in order for as powers of x. We got an x cubed, an x squared, and x. So that's the prettiest way to write it, but you can write it in any order you want. So that's all we needed to do there, simplify. So let's look at part D here. So number 1, they want us to multiply, right? So y'all might use FOIL for this, however you want to do it. Basically, you have a 2x, and it's being multiplied by an x minus 2. And then you have a positive 1, also being multiplied by 3x minus 2. So you have this times this thing, and this times this thing. So now we distribute again a 2x times a 3x, and then the 2x times the negative 2. And then we have a 1 times a 3x and a 1 times a negative 2. So 2x times 3x would be 6x squared. 2x times a negative 2 is a negative 4x. 1 times 3x and a 1 times negative 2. These are like terms, so we can write this as 6x squared minus x minus 2. All right, some of y'all might be able to do this in your head. This times this plus this times this plus this times this plus this times that is what it ends up being. All right. If y'all memorize FOIL, all right, you could use that, but FOIL won't work here because there's 3 terms, right? Basically, we have the 3x times this thing, and we have a minus 2 times the same thing. So we got a 3x times the 4x squared. We got a 3x times the 2x, and we have a 3x times the 1. That's just this, this, and this. Now we're going to do the same over here. We have a minus 2 times a 4x squared, a minus 2 times a 2x, and a minus 2 times a 1. Let's make some more room here. So 3x times 4x squared gives us 12x cubed. 3x times 2x gives us a 6x squared. 3x times 1. Negative 2 times 4x squared is a negative 8x squared. Negative 2 times a negative 2x is a negative 4x. And negative 2 times 1. Now we can combine like terms. See, those are the same, right? These are the same. So if we combine like terms, we have this 12x cubed. The 6x squared minus the 8x squared gives us negative 2x squared. The 3x minus 4x gives us a negative x. And then we have our negative 2. Okay. Now, one on division. All right, so we're dividing x plus 2 is going to go into 3x squared plus 2x minus 5. Okay. So let's see if I can remember how to do this. We need to get a 3x squared from an x. So you'd have to multiply x by a 3x. So I'd put that here in the x column. 3x times this stuff, that gives me my 3x squared, right? But I also get a 6x. And we need to subtract, just like we do in regular division. So 3x squared minus 3x squared goes away. A 2x minus 6x gives me negative 4x. Then we bring down our minus 5. Now to get a minus 4x from an x, we need to multiply x by minus 4. That gives me my minus 4x. But it also gives me a negative 8. I need to subtract these, so negative 4x plus 4x, those go away. Negative 5 plus 8 would be 3, right? So there's nothing else left here, right? So my remainder, we would have 3 over x plus 2, okay? That's how we do our long division. And that'll be good enough for 13.7. It's all fun stuff. Now let's look at this one. Where's my syllabus? No, that's not it. I need where's my syllabus? This one? No, come on now. There it is, syllabus. So it's chapter 13. So now we got 14, 1, 2, and 5. So chapters 14.1, 14.2, and 14.5. And this will be for problem number 9. Let's check out. Chapter 14. Factoring. Oh, this was fun, wasn't it? Y'all's favorite. So 14.1 is some simple stuff here. There we go. Find the GCF. Let's think. Factor out a negative factor. Okay, so let's make a problem up. For part A, factor out the GCF. So let's come up with a few of those. What if I had 2x cubed y cubed plus 4x squared y squared plus 8xy? That'll be a good problem. Let's try another one here. Let's do 9x cubed y plus 18x squared y squared plus 3 y squared. Let's do one more. 15x to the 5th y to the 5th plus 5x cubed y cubed plus 3x squared y squared. That'll be a good part A. And that'll cover 14.1 here, I think, fairly well. Now I need factoring by grouping. Okay. Let's see. We can do one like this. So B, factor by, I'll just say factor. I won't tell you how. Factors. So let's just pick this one right out of here. We had a 3ax plus 12a. 3ax plus 12a plus 2bx and 8b. So it'll be a good problem. Finish up 14.1. Yeah, so let's do this one here too. I'll write it down. 16w to the 4th minus 40. Make sure that's a 0 there. 40w cubed minus 12w squared plus 30w. And then we'd want a third one. Let's see. I'm going to invent a problem. If I have x plus 1 times x plus 3, if I multiply this out, I get x cubed and a 4x plus 3. So x squared plus 4x plus 3. Let's do part C. Check out the next section. So it was 14.1. We need 14.2, and then we jump to 14.5. Let's see what 14.2 wants us to do. Oh, factoring trinomials. Okay. Well, I just gave you a trinomial there to factor. Okay. So we'll continue to factor. This is all going to be factoring. Z squared minus 16z plus 48. Give you one like that. And now let's pick one that's a little different. Yeah, like this one. Has extra little guy in there. Negative 40t minus 30t squared plus 10t cubed. So that one's a little different because there's t's everywhere. So you could factor out a 10t before you finish factoring it. What do I have there? It's 2. Let's get one more. Oh, this one looks good. I like this one. So for third part, part C, we got a negative 3a squared plus 15ab minus 12b squared. Now part D will be for, what was that last section? They jumped to what, 14.5. Okay. 14.4, 14.5. Oh, the difference is squares. I'm not going to give those really, really hard ones. All right. Do some easy ones like this. Yeah. Factor. We'll do like y squared minus 25. And then I'll do 2x squared minus 32. And pick one a little more difficult here. Yeah, something like that. That looks good. W the fourth minus 81. All right, so that'll be our number 9. So let's work these here. So we need oops. Okay, so for chapters 14.1, 2, and 14.5. So here we want to factor out the GCF. So first we look at the number. What number can we factor out of everything, right? We can get a 2 out of everything, right? Now look at the x's. What's the least number of x's, right? This last one only has 1x. So the most we can take out everything is 1x. And for the y's, the same thing goes for the y's. So that would be our GCF here, okay? So what we would do is we rewrite this. We rewrite each term as 2xy times something. So the first term, we need an x cubed. We got an x, so that means we need an x squared, right? X squared times x gives me x cubed. Now for the y's, I have one y, but I need 3 of them. So I put a y squared there. So that is equal to that. Now we look at the next term. We get our 2xy. We need to multiply 2xy times something to get this. Well, we need a 4. We only got a 2. So the 2 times 2 gives us the 4. We need an x squared. We only got 1x, so we're going to need another x. We need a y squared. We only got 1 y, so we need another y. And now for the last term, we take 2xy. To get the 8, we're going to need a 4, and that's it. Okay. So since everything is multiplied by 2xy, we could factor out the 2xy. So we got a 2xy times x squared y squared. We all got a 2xy times a 2xy. And we have a 2xy times a 4. Boom, factored. Okay, for this one, let's find our GCF. Let's see, we can get a 3 out of everything, right? So I'll put my GCF, we need a 3. As far as the X's, this one doesn't have any X's, so we can't pull any X's out. Now let's look at the Y's. This one only has one Y. Everything else has more than that. So we can at least get a Y out. So 3Y is our GCF. So let's rewrite all our terms. This first term would be in order to get a 9, we'd need a 3. 3 times 3 is 9. We need X cubed. We don't have any X's, so we throw our X cubed in there. And we already have our Y. So 3 times 3 is 9. We have the X cubed, and then we have the Y. For the next term, we start off with our 3Y. To get an 18, we need a 6. We don't have any X's, but we need X squared, so we throw an X squared in there. We need a Y squared, but we only have one Y, so we need to throw a Y in there. And then 3Y. To get our last term, we'd have to multiply it by Y. That gives us our 3Y squared. Let's move this down here. So we have 3Y times each of these three things, right? We have a 3Y times a 3X cubed. We have a 3Y times a 6X squared Y, and we have a 3Y times a Y. And we are now factored. Now for this last one, let's find our GCF. I think we just see that I can't get a 3 out of this. I can get a 5 or a 3 out of here, but because I can't get a 3 out of 5 and I can't get a 5 out of 3, we can't really pull any numbers out. Okay, that makes sense. All right, so for the X's, we got 5, 3, and 2. So we can get an X squared out. For the Y's, we got a 5, 3, and a 2 again. So I can at least get an X squared, Y squared out. So if I rewrite this using X squared, Y squared, to get the first term, I need to have a 15 X cubed, Y cubed, right? That gives me the X to the 5th. That gives me the Y to the 5th. Now for the next term, I need that 5. I need X cubed, but I only have X squared, so I'm going to need an X. And the same thing goes for the Y. That gives me the X cubed. That gives me the Y cubed. Now for this last term, I just need a 3 here. So since everything has an X squared, Y squared multiplied by it, all right, I have X squared, Y squared times X cubed, Y cubed. I also have it times a 5XY, and I have it times a 3. Boom, factored. So that would be part A. So get part B here. So we can just go to the next page. Part B. So these, when you see 4 terms like this, the first thing you want to kind of start doing is grouping stuff. If you look at these and these kind of separately, this first 2 terms, I could get a 3A out of both of them. I need a X plus 4. See, that gives me the 3AX, and that gives me the 12A. Now over here, they both have B's. They're both divisible by 2, so I can get a 2B out. I need an X plus a 4 again. So this is what you call factoring by grouping. It just so turned out that we have an X plus 4 times each of these things. So this, we have a 3A and we have a 2B, both times X plus 4. This one's going to be kind of the same here. All right, so we look at these things separately and we hope it works out, right? These first 2 terms, Let's see, as far as the numbers, I can get what, an 8 out of both of those? And I can get a W cubed out. See, 16 is 2 times 8, and then the W cubed times a W gives me my W to the 4th. Now for the minus 40, I need a minus 5. 8 times minus 5 gives me minus 40. And then I already have the W cubed, right? This times this gives me this. Now over here, we'll try the same thing, factor out as most we can, and we hope that we end up with this same thing. So if I pulled out, let's say, a negative 6W, that's the best I can pull out. I would get a 2W and a 5. See, this times this gives me negative 12W squared. And this times this gives me, that's wrong. I need a minus. See, this is positive. So I need a negative times a negative to give me the positive. And that's a good thing because this is negative as well, right? We need it to be where this and this are the same. And we need that so that we can say, oh, we have an 8W cubed and a 6W, and they're both times 2W minus 5. It turns out we can factor this even more if you wanted to. See this term here? I can pull a 2W out of it. We would have a 4W squared and a minus 3. All right, so just looking at this, I could factor that out some more, right? This times this gives me my 8W cubed. This times this gives you the minus 6W. All right, that's fully factored. All right, but either one of these will be good enough. Okay, I don't think in this section they bothered to fully factor it. So either of those would be good enough. This one is one that you can just eyeball. When you look at this, remember these, you know it looks something like this. You know you need an X times an X. These are both positive, so you know this is going to be positive and this is positive. You need two numbers that multiply to give you 3, but add to give you 4. That would be 3 and 1. That times that gives you 3. You get a 3x plus an x to get the 4x. So this is one that you should be able to do just by eyeballing it, basically. Does that make sense? Y'all remember that? Okay, so that was what, part B. So the part C here. Okay, factoring this is going to be one of those that you should be able to eyeball like that last one. We got a z squared, so we need a z and a z. We need two numbers that multiply to give us 48, but add to give us a negative 16. All right, how are we going to add? If we add two numbers to give us a negative, but they have to multiply to give us a positive, that means they need to both be negative. A negative times a negative is a positive, but they would add to give us a negative. So we start thinking of all the different numbers you can multiply to give us 48, and we want the ones that add to give us 16. So what, 8 and no, 9, what multiplies to give us 48? 2 and, think about it, we got 1 and 48, but those don't add to give us 16. We got 2 and 24. They don't add to give us 16. What about 3? Is 48 divisible by 3? 48. No. Is it divisible by 4? Yeah, we could maybe 4 and 12, right? Yeah, there we go. 4 and 12. So that gives us our positive 48. We got minus 4z, minus 12z, and that's what gives us our negative 16z. All right, so that's how you do that one. This guy, if you look at this thing, you see that everything has a t in it. And everything, all the numbers are divisible by 10, right? And this minus sign at the front kind of sucks. So what we're going to do is we're going to pull out a negative 10t out of this thing. So if we did that, this first term would be a 4. And then the next term would be a positive 3t. And then the last term would be let's see, negative t squared. And actually, we'd want to factor this guy, right? Notice how it's written backwards. So that kind of sucks, right? So if we put it in the other order, right? We have this negative 10t here. Let's put these things in the right order. We have a negative t squared plus 3t and a 4, right? So we want to factor this, but this minus sign here sucks, right? So really, let's change all of these. All right. So it turns out we didn't want to factor out this minus here. We really wanted to leave that in. But if you bring this minus in, right, the t squared becomes positive, the 3t becomes negative, and the 4 becomes negative. So we want to be able to factor that. That now it looks like something that we can factor, right? See, they put these things in opposite order. The first thing we really should have done, instead of that, we should have put these things in descending order. We should have done this first. Okay. Then looking at it, we'd have been like, I can get a 10 and a t out of here, right? Yeah, I'll just leave it down here. We have plenty of room. All right, so first step, put it in descending order as far as powers of t. Then when we look at it, we could say, I can take a 10 and a t out of there and simplify it. Now this guy, I can eyeball and factor, hopefully. So we got a 10 and a t. And then this stuff here, we know we need a t and a t to get the t squared. Now we start looking at signs. I need two numbers that multiply to give me a negative, that add to give me a negative. If you're going to multiply two numbers to get a negative, one has to be positive, one has to be negative. So I need these two numbers to multiply to give me -4, but add to give me a -3. So if I did a -4 and a +1, that gives me my -4. I get a -4t and a +1t. So that works out. Now for this last one, let's see, we could factor what, a 3 out of everything. And since this is a minus out here, let's factor a -3 out of everything. So that would give me an a squared minus 5ab plus 4b squared. Okay, so just because there's a's and b's, that doesn't mean that we can't eyeball this thing, right? I need an a squared, so I put an a and an a here. I need two numbers that multiply to give me 4b squared, but add to give me a -5ab. Basically, you see that b squared there, you know you're going to need a b and a b. That's going to give you the b squared, right? All right. Now let's look at the signs. We need two numbers that multiply to give us a positive, but add to give us a negative. So that means they're both going to have to be negative. A negative times a negative is a positive, but they add to give me a negative. Now just looking at the 4, all right, two numbers that multiply to give me 4, but add to be 5. That would be 4 and 1, right? But we don't bother writing the 1, do we? Okay. So this gives us our a squared. This gives us our positive 4 b squared, right? The b negative b times negative 4b gives us the positive 4b squared. Then you have the cross terms. You got negative 4ab and a negative ab. And that gives you your negative 5ab. Okay. So that one would probably take you a little while trying to deal with the minus signs. But don't let this b squared here mess you up. Just because there's an a squared and a b squared, when you see that b squared, that means you know you're going to need to put a b and a b there. And then your cross terms, you're going to get these a times b's and your a times b's, okay? All right, so these are difference of two squares. Here, I'll go ahead and put a note here. Note a squared minus b squared is a minus b times a plus b. Remember your difference of two squares? So when we see this, this is y squared minus 5 squared. So this is going to be a y minus 5 times a y plus 5. The difference of two squares. This one, first thing I notice is I can get a 2 out of everything. Right? Then I notice that 16 is 4 squared. Now I have the difference of two squares. This is x minus 4 times an x plus 4. Part 3 here. All right, this doesn't look like something squared, but it really is. This is w squared squared, and 81 is 9 squared. So difference of two squares, this is w squared minus 9 times w squared plus 9. Boom, but look at this. This is also the difference of two squares, right? This is w squared minus 3 squared, isn't it? So this thing I could factor as w minus 3 times w plus 3. And then we still have this w squared plus 9, and there's nothing else we can do with that. Okay. The sum of squares we can't factor. The difference of squares we can. Okay. Where were we? So that'll be enough from chapter 14. So the syllabus says, well, I'm short on problems here. Hold on. That is number 9. I wanted to do 11 problems here. 9, chapter 14. Dang it. Where's my syllabus? So this would be number 10. So what I'm going to do then is this will be number 9. And this will be number 10. Because it's kind of deserving to be its own thing, right? So this will be number 10. This will be an A, and this will be a B. Oops. So let's fix that in our notes here. This is number 10. A and B. So now we have one more problem to invent. All right. Chapter 11.1 and 11.2. Okay. So chapters 11.1 and 11.2. This is number 11. So it'll be 11 problems, 10 points each. You can get a total of 110 points. And when I grade problems like this, let's see, there's going to be 10 points total, right? So I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, each one of these is going to be worth less than a point. Okay. So if you can't figure one out, that's okay. It's worth less than a point. Okay. Basically, if you get at least half of them, you'll get pretty close to full credit. All right. Okay, so let's look at chapters 11.1 and 11.2. Okay, graphs. This stuff wasn't too bad, was it? So let's see here. So let's do part A. Graph the points. So we'll make this part easy, right? So I want you to graph 1, 2. This should have been 1. -2, 2. And 3, -2. And -2, -3. Now let's get a picture of a graph and put in there. And I'll just draw one, right? Yeah, we can plot them all on the same. So it's X and here's Y. So that's 11A. All right, let's look at part B here. So you have to plot points. What was this, graphing, right? How good they want you to graph this. Come on. Scroll down. Okay. Determine whether it's okay. Yeah, so we just wanted to be able to graph. Okay. So determine whether these are solutions to, take one out of here. Do one like this. So 6x minus 5y equals 12. So 2, 0. Oops. 3, 1. and 1 negative 6/5. So that one should be hard. All you do is plug in your x and your y and see if the equations are actually equal. So it'll be easy. 2. Find the x and y intercepts. I just give you something to graph. All right, so let's do this. Let's do part C. Graph. Y equals 2x plus 1. And graph y equals 3x minus 2. That should be enough for chapter 11. All right. So let's take a short break. We'll take a 6-minute break. We'll knock out this last problem and then we can get out of here. Break. Break. Resume at 3:10. So what did we leave off here? We did problem number 10. So now we need problem number 11. Okay, here we go. So problem number 11, chapters 11. We want to graph these points. So for part 1, 1, 2, that means we go to the right 1. We have to go up 2. So on the second one, we got to go back 2 and up 2. The third one, we need to go to the right 3 and go down 2. And the fourth one, we need to go to the left 2 and down 3. It's as easy as that. The first number is right and left. Second number is up and down. So I can make these in red. Boop. 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 And I'll put a little arrow. That one. That one. That one. That one. And now our B. All right, determine whether these are solutions. So this is the X and that's the Y. So if we plug in 2 for X and 0 for Y, we get 12, which is the right-hand side. So yes. This one, we plug in a 3 for X and a 1 for Y. We get 18 minus 5, which is 12, right? No, that's 13, isn't it? 13, which is not equal to 12. So no. Now for the last one, we have 6 times 1 minus 5 times a negative 6/5. 6 times 1 is 6. Negative times a negative is a positive. 6/5 times 5 is just 6. 6 plus 6 is 12. So yes. That's easy enough, right? All right, and now we have C and D. So we just want to graph these. All right, so remember we need 2 points, right? So we can let X be any number we want and we find the corresponding Y. So if we let X be 0, we let X be 0, we could see right there that Y is equal to 1. And I'll write it out. Y is 2 times 0 plus 1, which is 1. So when X is 0, Y is 1. That is a solution. So let's plot that point. X is 0, Y is 1. So boom, right there. Now we need to find another point. The easiest one we could do is to let Y be 0. Let's let Y equal 0. Then we would have 0 equals 2x plus 1, or 2x equals negative 1, or x equals negative 1/2. So when x is a negative 1/2, y is 0. That's also a solution. Okay. So if we graph that, I'd have to go down a half and go to the right. Something wrong with this. These points should be in a straight line. Hold on. Oh. We go to the left a half and go up none. Got my x's and y's messed up. So that point right there is negative 1/2, 0. That point right there is 0, 1. We could put some tick marks here if we want. All right, this would be 2, be 2, this would be negative 2. So we have a sense of scale, right? This right here would be negative 2. That's really all you need. Now let's look at D. So one more to graph. Same trick, we need 2 points. So let's let x equal 0. If we do that, then y would be 3 times 0 minus 2, which is minus 2. So 0 minus 2 is a solution. So if we graph that point, 0 minus 2 right there. Now let's let y be 0. If we do that, then we have 0 equals 3x minus 2, or 3x equals 2, or x equals 2/3. So 2/3 0 is a solution. And now I can plot that. So if I go to the right 2/3, let's say this is 1. And this would be 2/3. Okay. First, this is negative 1, be positive 1. And then we draw our line. Okay, so this point here is 0, negative 2. This point here is 2/3 0. And it's graph. So we labeled enough tick marks. So we have a sense of scale for up and down and left and right. We plotted the points, labeled the points. And if you're unsure, you can always do a third point. Make sure that they're all on a straight line. Okay. And that's it. So yeah, the final looks like it's going to be like 15 pages long, but actually it'll be more than that because this is only the second half. So yeah, it might be like 40 pages long, but most of it should be short, quick problems. All right, and you'll have plenty of time. All right, if you need more time, that's okay. We're doing it via Zoom, so I will not be here. All right, the classroom will be closed. You can still go to the library if you need to be on campus. Okay. but that way you'll have all the time that you need. And it'll be very, very, very similar to what we've done in the review in the last class and this class. And you'll have access to these notes in Canvas. So that ought to help, right? All right, any questions? All right, let's eat some cake. All right, folks out there in Zoom land, do y'all have any questions? All right, I'll see y'all May 10th.